Come, all you moonshiners, if you want to hear.
Welcome back to Barley and Hops. I'm George. Today, I'm going to take it step by step slowly. We are going to build a 240 volt, 20 amp PID controller, and we're going to start. See, I got the box in plastic. We're going to start from that point, okay? And I'm going to work my way through this all the way so we'll get an opportunity to talk about a bunch of stuff at the same time. I'll show you exactly how I do this so you can do one on your own. Now, there'll be a little bit of theory in this, and so we'll stop at some points. Maybe we'll get out a piece of white paper and kind of draw what I'm talking about, because I want to make sure that everybody fully understands what we're doing. There is a difference between 120 volts and 240 volts. And of course, one's twice as much as the other. But we're gonna demystify every bit of that, okay? So I'm just gonna get started. And the first thing I'll do is just let me take this plastic cover off while we're talking. I get a lot of calls, a lot of emails, and I appreciate that, and it gives me an opportunity to interact with the community. Some of them are a little challenging. You must understand. I'm just going to leave it at that. Oh, but by and large, it's a wonderful experience, and keep it up. Well, I use a lot of weird tools, only because I got them. Make sure it's on lefty, righty, tighty, lefty, loosey. That sucker right, it's like an impact wrench. It'll twist the screw right off. I take the top off, and I've already got a cutout here because I'm going to be using an Inkbird. The Inkbird PID controller and the MyPin TA4 controller, they're both the same size. So all you need is one. This was cut out for something else, so I'm using this big square. I just place this on the upper left-hand corner and take my pencil and draw that out. Boom. That's where it goes, upper left-hand corner. That's where I put it. I don't care where you put it. It just tends to fit. Everything fits the way I put it there. All right, I'll move on to the next. See, next, then I take out my template for my receptacle. Now, and oh, by the way, this template fits both a round single receptacle for 240 volts, or it fits the double square receptacle. And I'll place that on the right-hand side. Trace a line around that. And that's where the receptacle is going to go. And what I like to do is I like to work on the top of the box, then I'll work on the bottom of the box, or vice versa, however I wind up going. It just kind of all fits together the right way. Okay. I get a lot of emails, I get a lot of questions. There's one I want to resolve right now. And this one just baffles me to no end. And I know people have bought that Chinese still, and that's a pretty good still. We did a review on that. And what comes with it is a box or a little plastic container, whatever the case may be. But inside, they find 3 hydrometers. And this is a proof and trail hydrometer. You see, usually the ones that we're accustomed to is just one hydrometer. It goes from 0 to 200. Well, they broke the scale down into 3 different ones. And I constantly get the question, George, which one do I use? And they're frantic. I don't know what to do. Which one do I use? Let's make it simple. Pour your spirits in a cylinder, okay? Drop one in. If it sinks, that ain't it. Grab the next one. Drop it in there. If it sinks, that ain't it. Grab the next one. That one should float. Or, in the opposite end, if you're working backwards and one floats way high, that ain't it. The next one doesn't float, that ain't it. The one that floats, it gives you a reading, is the one that you should be working with. Okay. Oh, and it all depends on your alcohol proof. If your proof is really high, you'll be using one of these. If it's really low, you'll be using the other one. If it's midway, you'll be using the one in the middle. Okay, so that should put a close to that. I get so many calls and questions about that, and I'm baffled. You got 3, just try one. All right. What we're going to do is we're going to move over. I'm going to actually work on the bottom of this box first. I've got this marked, and then I'll show you how I'll finish that up later. But we're going to work on the bottom of this box first. In the bottom of this box in particular, it has all of these little nuggets here where you can screw to. Well, I already know which ones I don't need. I don't need all of these down here. So I take them all. That just gives me space to work with. So I'm going to move over to the Dremels. I got some Dremel tools hooked up, and I'm going to cut them out. Yeah, see, I've got this on the other corner of the shop. So now see, the way I got this set up is all my Dremels, and I just put some toggle switches here. So I've got one pedal, one power cord in, and whichever toggle switch I use depends on which one of these are going to operate. And I'm going to use this one, so this one's number 4. So when I step on the pedal, it works. I'm just going to cut these out. There we go. That's as far as you have to go. You see, I got those bottom so many cut out. There we are. And it takes, you hear them going a little bit longer in there, and that's just because if you just cut them out, you'll leave some of it in there, and then nothing mounts flat. So you just want to flatten it out. So I got the box ready. Now my next step is always one of the most important tools I use around here is this little caliper. And what I do is I measure things over and over and over again to include screws, holes, things. Measure twice, cut once, okay? So the first thing I want to do is, here's my gland plug, which is how the electrical cord goes inside the box, and I'm going to measure this. This is a PG 13.5, I believe. Yep, PG 13.5. And then I've got the step bit, and I measure that, and that's absolutely goes right to there, so I know exactly how far down to go with my step bit. And now, well, I've got, you know what, if you make a mistake, you can always go back in and cut the rest of these out. But since I cut out all of these connectors on this side, right down here, well, my electricity is going to go in this way. So over here is where, so over here is where I need to put my hole. And that's just as easy as only go so far. And see, that fits right in there perfect. Now the next thing I want to put in is I want to put in a place for my fan. Now I always mount the fans so that they blow in and not blow out. And I'll show you the purpose of that here in just a second. So the first thing I do is just open it up and I just measure the size of the fan. What is it across the entire fan? It is that big. And I get a hole saw that is that big. And that has an arbor on the end of it, so it makes it easy. And since I put my cable going in this way, that means that my solid state relay is going to sit somewhere in this area. So what I want is I want to put my fan here and I want to blow this way. And then I'll put my vent holes on this side so that that air is constantly blowing across that and blowing it out. Now, the solid state relay does not get that hot. But in the event that it does, it's vented so it stays cool. I mean, that heat sink that's in there really does a great job of keeping it cool in the first place and dissipating that heat. But without a vent and a fan, that heat's got nowhere to go. So we want to make sure we give it somewhere to go. Now, this does not take a scientific measurement in which to place it. You just need to place it where you know it's going to blow across the components inside your box. You could in fact put that fan here. You could put it here. You could put it almost anywhere. But just make sure that your vent holes are going to be in a location like here where the air is going to go across the heat sink and out. All right. So I just choose to put my fan here because over here is where all of my other components are going to be, and I just don't want to get in the way of those. So I'll put it over here. And I just know exactly how far down. No, I actually put the hole in the middle of the box from top to bottom, and I'll show you. There you go. It's a simple cut. That's where the fan goes. All right. We're making progress. Okay. Now that we've got our fan hole here, I want to put the vents over here. Now, the only math to that is equal, okay? Whatever space you're going to use to flow air in, you need to have an equal amount of space for air to flow out. Here's what I mean is that if I put that fan here and I blow constantly in, and I'm blowing air inside the box, and I've got one small hole, let's say for instance here on the outside blowing out, what happens? Well, you start to get that back pressure, and a fan will do what we call cavitate. It'll spin, but nothing will happen. It's just spinning, but there's no flow. You've got to have an equal amount of space on this side as you do on this side. That's pretty easy to achieve. Use the same step bit and just go halfway in. And put several holes. Yeah, we're going to put one in the middle. And I'm going to put one here. There we go. Now, if you add up the area of all those holes, it will be larger than this hole, which means that I've got enough space to flow, for air to flow, across the box and out the other side. Simple as that. Here. Now, another tool that comes in handy is that flat razor. And I just use that to flatten off all of these edges so that anything I set on there sets flat. There we go. Now you notice how I did that. I just set the fan on the hole and exactly the way it's going to be inside the box, but on the outside. And then I just tap a little tiny hole in each four corners, because if you try to drill all the way through it, it'll move on you. Just make your mark, remove your fan, and then drill your holes. Now I do that with a bit that's just a little bit smaller. Just a little bit smaller than these holes, so that I can follow on with a bit that's the same size as those holes. And simply drill your 4 holes. It's a fine marriage between art, science, skill. I mean, it all comes together, So, and we're talking about things like airflow, fluid dynamics. That's really fluid dynamics. We're talking about airflow and the surface area, or the amount of space you need in order to be equal. We'll talk about electricity, all those things, and you'll fully understand why. When you look at your box, you go, I know why it works. Okay. Then just scrape off all those little high spots on the inside that are, trust me, going to get in your way later on. All right. Now, last but not least, or not last, but the next step, I got to find it. Here it is. 2 things. 1, insert your gland plug. I like to do that a little early. And I do it early on so that I can use super glue. And the reason I use super glue is because these have a tendency, when people start messing with them, of coming apart and falling off and looking really raggedy. So for those of you who ever get one of these from me, it's sucker super glued in there, and I do that so you can't get it out. That's the reason why I do that, so it always stays the same way. Pour a couple drops of super glue around those threads, screw it in tight, and just let it set for a while, because we'll come back to it. Now we're going to let this set and dry. Yeah, super glue dries pretty quick. Now there's another product. It's called Super Glue Activator. I'll show you. I'll use that in just a little while too. But this stuff right here, look out. You put down a drop of super glue and give it a spray, it's dry. It'll dry that fast. You take this spray, spray it on an item, put super glue on something, and touch it, it's immediately affixed. It's called Stick Fast Activator. Now, the next thing I want to do is I want to get my lid prepared, because I've got my base prepared. Now I want to get my lid prepared, because when I'm done, I just want to have everything, I want to do everything in one location. So and it doesn't matter to me if you do it backwards, I don't care. But this is just the way I do it. The first thing I'm going to do is I'm going to measure my base for my aviator plug that I use. See, it's an aviation plug. I use that to connect the thermal probe. And there you go. I mean, there it is. It only goes on one way. And that's the reason I got these, because even though the yellow plugs I was using before, only went in one way, I found out that there are people out there that can make them go in upside down. And if you do that, it reads backwards. So I got these plugs. These can only go in one way, so that eliminates that problem. Plus, they just look a whole lot better. So the first thing I'll do is I measure the base of this around the outside with my gauge. Some people call this, it's not a micrometer, but it's an outside measurement tool there. I can't remember the name of it. And I'm going to grab, the drill bit that I know works. There it is. And that's a pretty hefty bit. And I know where I want this. I want this right to the direct left of my PID controller. So, there we go. I just drill a hole to the left of my PID controller where I've got that marked. And that's where that will be so much easier. So the next thing I'm going to do is I've got another template for this, but I know that this is twice the size of this. So I will mark this in here, and I want that right below, not directly, well, directly below, but I want that right below there. So you see, I made my first mark, and I already know that this one is twice as wide as this one, so I just measured that. Lay that on there, and then since I'm here, double check the height. Yep, that's perfect. Score that with a pencil. There. So that's where my switch goes. Now that leaves me all this space down here. And that space down there is for, I call them donuts, but that's the sensor for the amperage. And this is just I like throwing these on here. If somebody buys one of these, it usually comes with one of these. And if not, it'll come with a small round one that's just the amperage only. And I use these because I just think it's just kind of neat to be able to look at something and it tell you what it is doing instead of just flashing. It's kind of neat to have that. And for the cost, I just sex the box up because I just think it's really, really an attractive addition. Not necessary, but really neat to have. And then I just lay that on there because I know exactly where I want it. You're going to see this and you're going to go, yeah, that makes a lot of sense. See, I just trace around it. I had visions one time of getting a CNC to cut all these out, but then to me that's just a little bit more problematic than I was willing to go through. Look, if I was doing 300 or 400 of them at a time, maybe it'd be worth it, but don't do that many. Okay, score that line good. All you need is a few marks just as a guide. And double check. Look at that. See, that just about takes up all the space on the front of my PID controller. Now you can also tell that this is not a 1, 2, 3 process. It takes a little while to get through, and we're gonna get through it. So what do you say? As I finish up now, I've got my base cut and prepared. I've got my top marked and prepared. I've kind of got everything else just about ready. We're going to end this. Stay tuned for part 2, and we'll pick up where we left off. Happy distilling.